All right, so we're going to look at the classwork on zero and negative exponents. So I will sort of talk quickly maybe on each of these problems, and you can check your work and let me or your other math teachers know if you have questions. All right. So if I have 58 to the negative 1, my base is 58. It's a big number, and we're used to more like 2 to the negative 1 or something like that. No big deal. It's just our base is 58 to the negative 1. So if I remember that that looks like 58 to the negative 1 as a fraction like that, I need to put 58 to the negative 1 in the denominator and change the sign of the exponent. So it's going to be positive 1. Okay, I don't need to write that I have an exponent of positive 1. That's implied, but 1 over 58 is the answer there. Here, remember, this is 5 times x to the negative 4. So 5 has an invisible exponent of positive 1. 5 is not going to change. Okay, so I'm going to keep 5 in the numerator. X to the negative 4, though, I need to move that to have a positive exponent. So we're going to put x to the negative 4 into the denominator and make it x to the positive 4. Negative 5 in parentheses cubed. Your instructions here are to write each expression in simplest form. And so I'm going to say negative 5 times negative 5 times negative 5. Negative 5 times negative 5 is positive 25 times negative 5 is negative 125. All right, 4 times a times b to the 0. Well, b to the 0 is 1. So I don't even need to write b to the 0. I can just write that as 4a. 1 over x to the negative 7. Remember, we don't like negative exponents, so if we want simplest form, we have to have all positive exponents. So we're going to move x to the negative 7 from its location now into a better location. It's going to go in the numerator and be x to the 7 over 1. But I'm not actually writing that over 1. I'm not writing it as a fraction. All right. 3 halves to the negative 2. This just means that my base that has a negative exponent, I'm going to move it to the denominator. So this is really 1 over 3 halves squared. Okay, that's a little messy, and I can certainly make that look simpler. That is really 1 over 3 halves times 3 halves. That is really 1. Well, I'm going to run out of room. Let's see if I have some space here. That is really 1 over 3 times 3 is 9, and 2 times 2 is 4. It's really 1 over 9/4. So that's really 1 divided by 9/4, which we do with keep, change, flip. So it's really 4/9. That's actually my answer here. So we're going to talk about this more a little bit later, but let me show you the easier way to do this. If you have a negative exponent, if I have 3 over 2 to the negative 2, and I have a fraction inside my parentheses, I can actually flip my fraction upside down, 2/3. See, I did the reciprocal there, and I can make my exponent positive. What, you say? That doesn't match what I have? Well, yeah, it does, because watch. If I then say 2/3 times 2/3, 2 times 2 is 4, and 3 times 3 is 9. So the shorter way to deal with exponents that have a negative exponent is to just flip them upside down and make your exponent positive. If you are insecure about that and you love dividing by fractions, then you can do it manually like I did here, longhand. I knew that I had to say that 3 halves goes in the denominator to get a positive. Okay. Okay, we'll come back and revisit that some more. 1 over c to the negative 1. I'm going to move c to the negative 1 up into the numerator, so it becomes c to the positive 1. It's 1 times c to the positive 1, and c to the positive 1 is just c. 3 to the negative 2 here, I need to move that to the denominator. My n in the denominator has a positive 1 exponent, so I don't have to move that one. Okay, and so remember that this is going to be 1 over 3 squared times n. Okay, and then I end up with 1 over 9n. Okay. Check in with your teacher if you're not clear on why you still have a 1 in that numerator. I'm just trying to make my videos a little bit shorter, but by all means, if that doesn't make sense that you ended up with a 1 in the numerator, please check in. Okay, k to the negative 4 times j to the 0. Well, j to the 0 is 1, so I'm just going to say k to the negative 4 is really 1 over k to the 4. Make sure you're trying these on your own and then coming back to check your work, even if you do one question at a time, because it's really easy to follow along with somebody else doing problems like these and be like, yeah, that totally makes sense. And then when you try to do it on your own, it makes a little less sense. So the idea of the classwork and homework and other practice is to make sure that you are able to do it on your own, but you can come back and check it here. All right, this is 3 times x to the negative 2 times y. So the only thing that I need to relocate is x to the negative 2. I still have 3 times y in the numerator, and x to the negative 2 becomes x squared in the denominator. Here, the only thing I need to relocate is c to the negative 5. I'm going to keep d to the 7 in the numerator and have c to the positive 5 in the denominator. That doesn't look much like a d, sorry. And c to the negative 5, d to the negative 7, well, they're both negative. They both need to relocate. And so that's going to be 1 over c to the 5th, d to the 7th. 7 times a times b to the negative 2 all over 3w. Remember, 7 has a positive 1, a has a positive 1. So if you don't see an exponent, you assume it's a positive 1. The only thing that needs to change locations and change from being negative is that b to the negative 2. So I'm going to keep 7a in the numerator. I'm going to keep 3w in the denominator, and I'm going to put b squared in the denominator too. I'm just rewriting so that I have things alphabetical, right? Because it's 3 times w times now b squared, but I put it in alphabetical order. All right. 8 over 2 times s to the negative 3. Be careful. Does that 2 have a negative exponent? Is the 2 moving up to the top? It is not, right? It has a positive 1. That 2 is happy where it is, so we're going to leave it where it is. So that means that I have 8 over 2, and I bring s to the negative 3 up into the numerator, and it becomes s to the positive 3. Now, of course, you would never want your math teacher to have to do any math. You do the math. So 8 divided by 2 is 4. I have 4s to the 3rd. Okay, and again here, you're just moving things that have a negative exponent, so that t to the negative 3 will move. So I have 7st to the 3rd all over 5. 6a to the negative 1, c to the negative 3 over d to the 0. D to the 0 is 1. So I'm going to have 6 in my numerator. And I'm going to put a to the negative 1 down below, so it becomes a to the positive 1. C becomes c to the positive 3. And that is my answer to that. Only move things that have a negative exponent. Okay, so 2 to the negative 3 is going to go to the denominator. It's going to become 2 to the 3rd. Z to the negative 7 becomes z. Ugh, somebody's hurting me with these letters. Z to the 7. And I keep x squared in the numerator. But wait, there's more. You can do this. You know 2 to the 3rd is 8. So we're going to say x squared over 8z to the 7th. Okay. 12 to the 0 times t to the 7 times u to the negative 11. Well, anything to the 0 is what? 1. And I'm left with t to the 7 over u to the 11. S to the 0 is 1, and 2 to the negative 1, I'm going to relocate that. I'm going to relocate t to the negative 5. Okay, so in my numerator I have 7, and I'm going to bring up 2 to the negative 1, so it's 7 times 2. And in my denominator I have m squared, and I'm bringing down t to the 5th. I end up with 14 over m squared t to the 5th. And finally, 2x to the negative 3 over 3 to the negative 1. I'm relocating x to the negative 3, and I'm relocating 3 to the negative 1. So I have 2 times 3 to the positive 1 in the numerator, and x to the 3rd in the denominator. That is 6x over x to the 3rd. All right, so that's a whole lot of stuff. That is your information on the classwork with 0 and negative exponents. So the other thing that we want to work with is scientific notation. And I'm going to do a different video with the scientific notation notes. Thanks for watching.